So today we're going to start solving systems of equations. And we'll do a little review before we get into that. So it says give a solution to each equation. Now I hope you realize that both of these equations, A and B, they would both graph out as lines. And a solution just means a point that's on the line. So there's an infinite number of solutions. Okay. For example, whoops. Let's just pick an x value, 1. Now, when you plug that in there, 3 times 1 is 3, and 3 minus 4 is, you'd get a y of -1. But remember, there's an infinite number. Like, look, you should recognize this is slope-intercept form, y equals mx plus b. So 0, comma, -4, that would be a spot too, because that's the y-intercept. But you could pick any y. Look, if I pick 10, whoops, my pen just... And if I plug 10 in, 3 times 10 is 30, and 30 minus 4 is... My pen is not working correctly here. Is 26. So my point is that there's an infinite number of solutions to one equation. It's just a point that's on the line. This one, same thing. It's a little bit harder to do, but you could do like the intercepts, right? Like every x-intercept has a y of 0. So this would go away. 2 times what is 18? 2 times 9. Of course, you could do the y-intercept, -3. If I plug 0 in here, this goes away. -3 times -6. That one's a little bit harder to do in your head, but you could solve it for y like a and come up with an infinite number of points. So a solution is just a point that's on the line. That's all it means. Okay? So is 7 comma 2 a solution to -12 plus 6y equals 0? Well, all we have to do is plug this in, right? Plug in the 7 for x, plug in the 2 for y, and let's see if this equation works. -12 times 7 is -84. -84 plus 12 is clearly not 0. So this answer is no. Okay, that's all it means. A solution is a point that satisfies the equation, which means it's a point that is on the line. Now, what we're going to start to get into now is we're going to talk about systems of equations. Okay, a system of equations means you have 2 or more lines in the same problem. And we're asked if this is a solution to the system below. For this point to be a solution to the system, it has to work in both equations. Not just one, but both. Okay? So let's just plug into the top one. -4, we'll plug in 3 for x. And if I would get -12 plus -1, and that would be -13. But remember, that doesn't mean it's a solution. We have to try the second one too. So this says -x, so that would be -3 minus 2. Remember, -3 minus 2 is -5. So it doesn't work there. So this one is no. So again, must work in both equations to be a solution. Ugh, my pen. It's a new battery too. Of a system. Okay? Has to work in both. Now, I'm hoping that you're thinking, again, for a point to be a solution to a system of equations, it has to lie on both lines at the same time. So the point that lies on both lines at the same time is, of course, the point where the lines are going to cross, where they intersect. So all we're doing is finding the point of intersection. So now we're going to draw on our vast graphing skills. So look, this first line here, It's in mx plus b form. There's the y-intercept. My slope is that invisible 1, so that means up 1 over 1. Now I'm going to make a bunch of points. Before, when we were graphing lines, I would often only do 2 points and then draw the line. I'm going to move with the slope a bunch of times, and you'll see why. Try to draw a neat line. Now I'll do the other one in blue. -6 is the y-intercept. And my slope is 2. That means up 2 over 1. Up 2 over 1, and you see how I'm getting closer to the red one. Up 2 over 1, up, there's the magic point. Let's go a couple more. And there is my second line. You should graph both the lines. And of course, that is the point of intersection. Now, what is that? 1, 2, 3, 4, up 2. So 4, comma 2. Okay? So there's only one solution. That's where the lines intersect. Now, remember, there's an infinite number of points that are on the red line. There's an infinite number that's on the blue line, but there's only one point that's on both the lines at the same time. Now, if you want to check it, this point should work in both equations. Look, if I take the 4 and plug it in here, 4 minus 2 is 2. I got 4 comma 2. Good. If I plug the 4 in here, 2 times 4 is 8. 8 minus 6 is 2. It works. This should work in both. All right. Here, let's do another one. Now, the first one here, that one's easy because it's already in slope-intercept form. Now it says down 3 over 1. I'm going to make this a little bit bigger. 1, 2, 3 over 1. Now I can also go backwards. Remember, instead of down 3, right 1, I can go up 1, 2, 3, left 1. Same line. 1, 2, 3, left 1. 1, 2, 3, left 1. Okay? So there is the first line. Now the second line, we have to do, it's not in point slope form, it's not in slope, we have to change it to slope intercept form. So that means get y by itself. So I'm going to go down to the -4. Actually, we already know our actually, what do we have happen here? We have an interesting situation here, right? What happened when we solved this one? We came up, see, it says down 3 over 1. We came up with the same exact line. Both of these equations were exactly the same. So this is a special case. This is where we say infinite many solutions. Because where do these lines cross? They cross everywhere on the line because the blue line and red line match up perfectly. So there's an infinite many solutions. You have both of these equations are exactly the same. Okay. Now, in the next one, you can imagine, well, we'll cross that bridge later. This one here, remember, I'm going to do these quickly. X equals -2. Remember, X equals a plane number is always a vertical line. Okay. And then the other one I'll do in blue. I have to solve for y first. And you got to be careful with your negatives. See, the negatives cancel there. So there is my y-intercept. I have to go up 3 over 2. But that's taking me away from the red line. So now I'm going to go, whoops, I did that wrong. Let me careful. Up 3 over 2. I'm going to go backwards, down 3, left 2. And you see my point is right there, which is what? -2, comma, 1, 2, 3, 4, 5. And again, if you want to quickly check, you can plug into these. 3 times -2 is -6. This is going to become a +10. That's going to be right. Okay, so we have to do a little solving for both of these. I'm going to subtract 3x from both sides. So I get 2y equals -3x plus 6. Y equals, okay, so there's the blue one. Down 3 over 2, down 3 over 2. And I'll go backwards once. This is why it's good to have graph paper, folks. Here I just have to divide by 4. Now be careful when you do this. Remember, this does not become 4x. That's 1/4 x. 1, 2, there's my y-intercept. I have to go up 1 over 1, 2, 3, 4. Actually, we found the intersection right away. 1, 2, 3, 4, 1, 2, 3. So 4, -3. And there you go. That's how you find the solution to the system by graphing. Graph the two lines, find the point.